Ok, pornesc imediat live stream-ul, te anunț când e gata și poți să începi. Pot să și anunț dacă au întrebări sau ceva, pot să le pun în chat.
Chatul de pe Zoom?
Sau YouTube.
Ok.
Ok, suntem live. Poți să începi.
So, hello everybody. How's it going? I can see already some participants here. So, welcome to Alexandra Savescu, Victor K, F. Andrei. Good to see you guys. I don't know if this feature is supported in Zoom, but can you raise your hand if you can hear me, if everything is fine? See that we're already 3 people in.
Yeah, so we have a few people here, and also on YouTube we have 3 watching.
Awesome. Yeah, we're gonna wait just a few more minutes for everybody to come in. Because on the official website, on the meetup event, we have like 37 people registered. Can't wait to see how many of them are actually going to make it. So can you confirm, Bogdan, that there are 4 people besides us?
Yeah, so we have 5 on YouTube and we have, I think, another 4 people here. I think you can start.
Okay, so like 10 people in total. All right.
Yeah.
Okay, so hi everybody. My name is Teodor, and today we're going to take a deep dive into dependency injection. Well, not kind of that deep, but just like a brief overview and some of more advanced stuff regarding this very, very fancy method of achieving the D principle, the dependency inversion principle, which is stated in the Solid Principles by Robert Martin. So first of all, I'd like to say that I totally suck at PowerPoint presentations. I mean, it's not really my thing. And the last time I did this, I think it was back in university at my diploma examination. And even then I was using LaTeX. I was not into slides really. So please bear with me. And if the style is not right, you can throw those on me. I don't mind. I know I'm not that good of a presentation guy. Okay, so in today's agenda, we have, well, let's say 3 main topics. We'll start with an introduction, both of me and the subject we're going to discuss today. Then we're going to take on some more advanced stuff. And finally, we're going to build our brand new, fancy, shiny DI framework. So, all right. So, yeah, if you have questions, yeah, just put them in the chat. Yeah, we're gonna answer the questions at the end, or if Bogdan says so. So feel free to ask any questions here on the YouTube chat. All right, so let's start with the introduction. Yeah, let's start by presenting the presenter. This is actually a screenshot from my CV, which you can find online at carpathiancoder.dev. You can find the link in the chat. And yeah, so I'm a .NET developer. I've got almost 6 years of experience in various industries. I'm based in Iași, and as you can probably see from the background, I'm doing the presentation from FabLab, which is a close collaborator with .NET, with .NET days. And after spending some years abroad, most notably in Austria and France, I came back to Romania to attend to my mother, and to become a better developer here in Iasi, contributing to the local team. So my area of expertise is .NET and Angular. Right now, I'm a full stack developer. I have 2 clients, which I'm not going to disclose them. Right now, like I said, that I'm a professional freelancer, because I'm part of a bigger community of freelancers called Baza Shapte. And yeah, this is what I do right now. I provide consulting services to various enterprises. All right, so if you want to connect, drop me one of the Join to Connect buttons, and we'll see each other on LinkedIn. Okay, moving forward, let's get into some fundamentals of dependency injection. So first of all, we have to define problem. Actually, the problems, because there are multiple problems. So what is actually dependency injection? Dependency injection is an architectural pattern, and the implementation of the inversion of control principle. So as stated in the solid principles, we take the D, which is my favorite, the dependency inversion. And that means that it means that basically you have 2 things that depend on each other, and you invert the control of it in order to make things more flexible. So let's start with a simple example, the car engine problem. Okay, so we have a car. I'm really passionate about cars, by the way. I own like 3 cars, and I really like driving and all that stuff. Yeah, we have a car and we have an engine. We also know one car can have multiple engines. So we can have cars that run on diesel, cars that run on petrol, cars that run on electric power, on hydrogen, AdBlue, LPG, etc., etc. So there are many types of cars. And one would think that in order to change the car, you would need to change, in order to change the engine, you would like to build a new car. But that is not really the case. If you go to one of the vendors, like Ford, for instance, you can find the same car with different types of engines. And that is achieved by using, in a more simplistic term, the dependency injection principle. So in this image here, in this simple diagram here, we have a car that depends on the engine. That means that if we change the engine from petrol to diesel, we will have another car. We would have to build another car, and that's expensive. And we as software developers, we don't like expensive stuff. We like to keep it to a minimum. And this is where it comes to the solution. The solution is to depend on abstraction. Abstraction is either an abstract class or an interface. The latter is preferred. So there we have it. You have an iCar engine, which is an abstract thing, an interface, which, for instance, could have a generic method like start or service, like start the engine or just put it into service mode to be able to be operated by mechanics. And using this approach, we can actually inject or use multiple types of car engines. On one side, we have the petrol car engine. On the other side, we have the diesel car engine. And we can add multiple implementations of it. The main idea is that the car should not depend on a single type of engine, but rather on an abstraction. In this case, an iCar engine, which can have these 2 functionalities of starting and servicing. All right. So the next example. Here there's a pretty common scenario that I've encountered in my experiences, mostly in big corporations, and that is tying the application to a specific database. So let's say that, I don't know, my big company, which has 100,000 employees or so, decided to take on a contract with Microsoft. And Microsoft told them, hey, there you have the license for SQL Server. You will only use SQL Server, and that's it. And marketing, being very efficient, can actually push some managers to take this decision, which on the technical side is not very good, because I don't know, maybe one day you want to change the database provider, you want to go open source, or you want to change the, I don't know, the licensing terms, and you are tied to one database. For instance, Microsoft SQL Server, which I mostly encountered during my work experience. So in this diagram, let's say we have a generic service. We can imagine having like a web service user controller behind, and that user controller calls the service, and the service calls the repository, and the repository goes into the database, makes an actual connection to the database, gets some of the information, and then, I don't know, display it to a phone screen or something like that. And this is fine. I mean, it's working just fine. The problem is that, as I said, what if one day the database is no longer supported? I mean, what if you want to change the database support from SQL to NoSQL? How easy it is to change your database and to get the benefits of flexibility. Unfortunately, using this model, you cannot. Oops, my bad. A second, I clicked the wrong button. All right, there we go. So we have here, we said that we're getting back to the database problem. So yeah, what if you want to take advantages of both words and use a NoSQL and SQL at the same time? What do you do? So in this case, the solution would be to extract the logic of creating a database connection into a connection factory. All right, I just lost my notes, so I think yeah, I should better get my notes here. All right. Okay, everything's fine now. So the database connection solution. So instead of tying yourself to a specific database, I would suggest extracting the logic of connecting to a database in an interface. So for instance, you have an iConnection factory, and this interface would provide just a simple, like get the SQL connection, get Mongo connection, get Redis connection. I recently used Redis, by the way, and it's super cool. I really like the way it works. And then you have multiple implementers, multiple inheritors. So you would have one SQLDB connection that provides a factory. Then you would have the Mongo, the Redis, and so on and so on. And the user repository would just contain a reference to this connection factory, which can be of multiple types. Man, this is the power in it, because one day you keep the same logic in the user repository, but you completely change the database provider. And that for me is super cool because it allows us to avoid obsolescence. In one way or another, market times are changing, and things that work today will not work 10 years from now or even 5 years from now. So we should keep an eye open on the flexibility. Oh, so the third example. This is like the bonus problem. I don't know how many of you guys work with datetime, like in production code, and trying to test the datetime No, it's pretty complicated if you do not use an abstraction over it. So let's suppose that we have a greeter that says, based on the time of the day, says like good morning, good afternoon, or good evening. And if we look at the implementation, the create a greet message, we take into consideration the date, time, now, hour. So if what time is today? What time is now? So it's like 6:45 p.m. or 18 o'clock. That would be like good evening. And how can we actually test this? Let's say you want to test for if the good evening message appears, but you're testing in the middle of the morning. What do you expect it to be? Yeah, you cannot. If you test it during the morning, you'll get a good morning. But if you test it later time in the day, you'll get a good afternoon or good evening, like is the case today, like case now. And what you should do is to actually put that logic of getting the current hour into an interface. And let's name that interface iDate provider. That pretty much solves it. So you have one implementer, the system datetime provider. Since you can have multiple datetime providers, you have a mock one, you can have other implementations. There are lots of NuGet packages on this topic. And in the constructor, you can see that we are injecting this iDatetime provider. So we can mock it if necessary. This is one of the main advantages of dependency injection, is that first of all, we can make our we can make our code more testable because we can use mocks everywhere. We do not need to tie implementations one by one. We can reduce dependencies. That means let's imagine in this constructor, that in this constructor we have like 5 providers or 7 services. How would that constructor look like? Like new datetime provider, new log collection, new, I don't know, system network provider, new user repository. You just put in a bunch of dependencies there, and it makes the code so much harder, so much painful to test. And this is where dependency injection comes in, and it allows you to register multiple services and just call the one you need. We will see that in a moment. Okay, so now that we got the basic introduction, let's see how Microsoft does it. How it implements this dependency injection framework. Well, it actually does it with 2 main components: the service collection and descriptors, service descriptors, to be more accurately. So let's see an example. This is like a classical web application in which everything is put in one file. And if we go line by line, we can see that in recent versions, like in .NET 6, I think, they created this web application .create builder using the arcs that are being passed by the application. It's like the minimal API with the minimal startup. So no ceremonies. Startup.cs is gone, and right now we can do everything in program that .cs. So we can say that we have a builder. Basically, we have a builder, and then in this builder we can access the services container. This will be our dependency injection container, the services, which is a collection of service descriptors, as we'll later see. So we add controllers to our application. We add endpoints. We add SwaggerGen in order to have documentation. We must have an HTTP client because if we make calls to external APIs, certainly need that. And then we have something interesting. This is custom code, add weather services. And we'll see that in a moment. So these are like the basic steps to configuring your web application. And furthermore, we have multiple ways to add services to our dependency injection container. First of all, based on lifetime, we can have singletons, transient, and scopes. And scope is usually defined only in web applications where the scope is like the same request. So when you send a request to a web server, every call in that request is recommended to use the scope lifetime in order to get consistency across the requests. Then we have transient, which means that at every call, the framework will create a new instance of that service. So every time, let's say we have an ID generator, which is a GUID, which does GUID.new. If that's a transient, it will return a new ID every time it's called. And then we have the most famous of all, the singletons. That means that when you start your web application, you could have at most one instance of that service you're registering. So in our example, we have a mapper, like a generic mapper, which takes, let's say, a DTO and converts into a business object, or takes a business object and maps it to a database entity. And then we have a logger, logging, which is very important nowadays. And yeah, this is another type. So we talked about lifetime, and now we're talking about types of or better ways to configure this matching approach, because at the end of the day, the service collection is just a dictionary which maps an interface to an implementation. So in the first case of the case of the mapper, you take the interface, you provide implementation, but you could also do more generic stuff, like take the type of the iLog adapter and map it to an implementation of the logger adapter. And that is how you inject generic stuff, generic classes. So moving on, we have the builder. So when you call the build method on the builder, it returns you like a ready-to-run app. Of course, you can check the environment and add some more documentation if it's in the development stage. Use HTTPS because it's required nowadays to have certificates running. Also, you could use authorization for various cases. And yeah, you just map your controllers and run the application. And this is what the flow looks like. So I said earlier that we have some custom code that we have to look into, and that is the add weather services. Okay, so yeah, I'm using Rider, by the way. So if you see some Rider markup, just ignore it. It's one way to disable some of the crazy stuff the compiler does in Rider. So as you can see, we can actually build extension methods. This is an actual extension method. So going back, we can see that we have builder.services that add weather services. So we can actually build an extension class for this service collection, which takes an interface, by the way, an iService collection. And then we can use a descriptor, which is a very fundamental term, to extend this collection. In this example, we map the interface of iWeather service to the implementation of Open Weather service, which is an Open Weather service which you can use to query like the local time, the local temperature, and the meteo in general, and providing a transient lifetime. So that means every time you'll call the Open Weather service, it will return another response. And then we can add another mapping. So we have the same weather service, but we can implement it with an in-memory weather service in order to preserve our tokens. Because as you probably know, public services are paid. I mean, you get like a free trial, but then you need to pay. The more requests you make, you need to pay it. And voila, you can add your descriptors in the collection, and you're done. You can go back into the web, into the flow of the application, and make it nice and clean. All right, now some more theoretical stuff. As you've probably seen, dependency injection is mostly used with constructor injection. Of course, you can inject dependencies in multiple ways. For instance, I personally use the property injection. So basically, when you create a new object, you can specify what type of implementation you want to use. And you can also do method injection. You could have a method, let's say like get users, and you pass in the connection, the database factory that you want to use. So we have property injection, method injection, but by far the most popular one is constructor injection. And usually when you use constructor injection, you prefer to use composition over inheritance. This is not something new. It's been around since, I don't know, at least 27 years. As that's the year the Django 4 published the design patterns book. And yeah, they specify clearly that composition is preferred over inheritance. Just a quick note, in one of my experiences, I encountered some projects that were using like 9 levels of inheritance, like 9 custom frameworky stuff that had like 8 or 9 levels of inheritance. It was impossible to test. It was like super heavy. And yeah, just a pain to work with. Yeah, so remember, whenever you want to use inheritance, just think about the consequences. And yeah, at least for my sake, use composition. It's a way better. It's a better way to do things. All right, let's move on to some more advanced stuff. So let's start with minimal APIs. Well, it's not that advanced, but it's pretty new. So I guess it deserves some credit. In minimal APIs, you won't see controllers as much. They're still used, but we put emphasis on endpoints. This is the core of minimal APIs, mapping directly implementations to endpoints. So if we skim through it, you can see the same web application crate builder that is provided by the .NET Core framework. And then we add an HTTP client, again, for making external API calls. And then we add our service, our open service, open weather service. And then we build the application. And after building the application, instead of mapping the controllers, instead of getting the logic from the controls injected in the application, we can actually map these endpoints directly. So in this example, we expose the weather endpoint and then the city, which will be a parameter. So for instance, we take the city of Iași. You can say like weather Iași. And then, yeah, use that parameter to get the weather. And as you can see in the parameters in the body of the function, we use the weather service, which is injected by the minimal framework, the minimal API framework. So whenever we specify that we need an iWeather service, voila, you can use it in a method. So in this way, you could have any implementation, but just use the interface to do your job. In this case, to get the weather. All right. Okay, so a few ways to resolve dependencies. We can resolve dependencies in many ways. For instance, we can use it from the constructor, from the method, from the property. We can use it. We can use the HTTP context actually to solve some dependencies. We can use the context is especially useful when resolving it through action filters and attributes. We'll also get middleware, but we're gonna take a simple example in console applications because I've seen lots of projects which are console applications, like huge console applications. And yeah, we'll see how we can do it. So one way to resolve dependencies here is with method injection. So again, this is a minimal API. We can see that map_get is an actual method. It's a method that takes the resource as a first parameter, and then it returns a func. It returns a function, and in this context, we can inject our dependencies. For instance, the logger. All right. Yeah, so there are multiple ways of registering or resolving dependencies. This is one of the most common. All right. So moving on, we can have a very nice discussion of coupling and cohesion. The question being, do I need an interface for everything? I mean, I've seen places where interfaces are used everywhere, and places where interfaces are almost never used. And it comes down to this basic question: how would you have your application behave? How would your application be? Will you put emphasis more on coupling or on cohesion? In general, things that change together should go together. And this is the principle behind cohesion. So when talking about cohesion, you want to group things closely together so that it makes sense. It makes logical sense. For instance, when you have a business entity, let's say, I don't know, like a person, we're talking about, let's take the example of like a credit card application. When you apply for a credit card, you have lots of like background checks and reference check. And you should keep this like huge business object together. You have the person, you have the credit card, you have his background, you have his financial, you have his score, you have everything. So this should be put together. No interfaces whatsoever, because that will complicate things. On the other hand, we have coupling. So the principle behind coupling is that we should have separate components that can be scaled, for instance, based on usage. So if you have a monolith is the definition of high coupling. Like you have one project, you have one application, and if you want to change something in that application, yeah, you have to like redeploy it. You have to make another copy of it, put it on another server, and this can be very, very expensive. In general, the principle is like low coupling and high cohesion. You want to keep components as cohesive as possible, but not really coupled. One of the recent examples where I felt this principle was when I was working on a front-end application, and I was supposed to make a query to the database and get response, and the application would just freeze. For I know like 5 to 10 seconds, and yeah, it was because first of all, we were not using async await, so the main thread, the good thread, was blocked. And then yeah, we had this very tight coupling with our backend service, which shouldn't have been. Okay, time is ticking, so we're getting close to the end actually. So after this more or less philosophical question of do I need an interface for everything? The answer is it depends. I personally prefer interfaces because like less interfaces, great problem. But more interfaces is usually a good sign of good health. That often means that testing is involved, and you can basically move things together, have more flexibility when you put things behind interfaces. Okay, so we're approaching the end. This is like the final section. What about creating your own dependency injection framework? How hard is it? Well, let's see. So if you're one of the guys who, I don't know, don't believe in external dependencies, I believe you. I worked in teams where I don't know, the project manager was not into like external dependencies. So we say, okay, guys, let's build everything in-house. We'll just start everything from scratch. We're like in a very tight business scenario. We had a team that managed our infrastructure. It was really hard to publish like external NuGet packages on that server due to security issues. So yeah, if you want to create your own dependency injection framework, yeah, let's go ahead and do it. Actually, from my point of view, you should not use I know other frameworks, other dependency injection frameworks, because I think it's just overkill. I was looking at ninject, at Castle Windsor, at Autofac, at Light Inject, Lamar, Spring.NET, LeanFu. So there are lots of dependency injection frameworks, but once you get down to the basics of it, it becomes pretty straightforward. And I personally think that you don't understand a thing at a deep level until you break it down to smaller pieces, and then like reconstruct it. This is how I did programming in general. I took like a big part of it, broke it into smaller parts, and then digest it one by one, and then reconstruct it. This is how I learned to do stuff. And yeah, just to answer Alex's question, because it's like now relevant. Yeah, now .NET has built-in dependency injection. Do you still add the libraries? The answer is no. So Microsoft did a pretty good job, and now, as we'll see, we can make our own dependency injection framework pretty quickly. So no, I would not use other libraries just because doesn't make sense anymore. You can build your own stuff. One thing that I forgot to mention was that so one of the advantages of low coupling is that you can deploy services, you can deploy independent stuff on multiple machines, for instance. One of the examples that comes to mind is the Black Friday. Maybe I'm sure many of you heard about Black Friday issues on the servers, because like everybody connects to the website at the same time. It's like a DDoS, and the server just can't handle this flow of users coming in. And if you see one of the websites you go shop to fall down in Black Friday, it means that they have really high coupling in their applications, so they cannot scale it very well. So one of the main advantages of low coupling is that you can scale both horizontally and vertically. Okay, let's take a simple, like the most basic example of how to use dependency injection. As you can see, it's only 5 lines of code. Okay, so you start by a service collection. By the way, this is built into Microsoft DI, so you can use it as it is, the most basic example. So we have a service collection, which we would add a mapping, a descriptor to it, and all you could say. So you would add a singleton, that is the lifetime. Then you specify the interface and then the implementation. Of course, you can have multiple implementations based on your use. And bonus tip, you can actually remove services. So for instance, I don't know, maybe you get a request to change the implementation of one of your database connections, for instance, dynamically while the application is running. You can actually do that by removing that singleton and replacing it with another implementation. So there you have it. You take the service collection, which is the container for your dependencies. You specify the lifetime, like add singleton or add transient. You mention on one side the generic type of the interface, and then the concrete implementation on the right side. And then you have a provider. So this is like, for most of you, will be a new term. We have this service provider, and this service provider, well, it does what its name suggests. It provides services. And so you have the container, then you have the provider, and then you use that provider to get your service. So for instance, in this case, we just tell the provider to provide us the iConsole writer. And yeah, we just use it. Use the console writer as you'd like. And all the complexity of constructing this console writer is done by the service collection itself. So okay, let's see more in depth of how it works. So let's start by constructing our own service collection. So remember, this is not the Microsoft one. This is our own service collection, and basically it's a collection. So it's a list. We can use, in this case, the inheritance because it makes more sense. The service collection is a list. Is a list of service descriptors, and we'll look into them later. The first line in our code is to add a singleton. So let's create that definition. We add a singleton. So we have a method called singleton. We return the service collection itself because we would like to chain multiple methods to it. And we specify the constraints. So the T service, the type of service, should be a class, should be interface, and then the implementation should inherit from the service. All right. So in here, in this body, so what we do with this service and implementation, we create a new descriptor. We create a new descriptor which we will add to our collection, because remember this is a list, so it adds to itself this service descriptor using the lifetime of singleton. Okay, moving on. Well, not moving on. Let's go deeper into this. So we have add service descriptor, and we can configure it with the three attributes that it has. It has the service type, the implementation type, and then the lifetime, which in this case can be either singleton or transient. And we have this built service provider, which is the third line. And we actually take a parameter, the service collection itself, to get the provider. Okay, so let's take a look into the service provider. We're starting to get into some more advanced stuff as warned. When it comes down to adding stuff to a collection, we have to use a dictionary. A dictionary because at the end of the day, we just have mappings between interfaces and implementations. And since we have only 2 lifetimes, we're going to need just 2 dictionaries, one for the transient types and one for the singleton types. The code is mostly the same, but we'll see later in this generate services method that we iterate over these descriptors, and based on the lifetime, we construct them differently. So for the singleton, we're going to use a lazy object, which is built into Microsoft. A lazy basically tells us is a definition of singleton. So when you get something, you check it if it's null. If you don't have that instance ready, you construct it at runtime. But if you already have an instance, you just return it. So this is what lazy does. And that func given is actually the factor method. So it will return the instance if it already exists, but otherwise it will create a new instance. And yeah, it will have the implementation type. So either the implementation type which is given by the service descriptor. And on the transient side, it's more easy because you just map the service descriptor, the service type, the implementation to the actual the interface. You map the interface to the implementation in the dictionary itself, and that's all. That method below the get constructor parameters uses some very nice reflection going on. So we'll basically recursively match the parameters. So if you can see, just at the end of the slide, you have this get service, and you take the type of the parameter. So basically, like get service, and yeah, you basically take objects and recursively iterate for them to get the instance that you're looking for. Okay, so this is the service provider. Well, it'll be complex, but not that complex. I'm sure you're following along. Okay, so what exactly is a service provider? Well, it's not that big of a deal. Actually, we have just a get service, which returns a generic object. And if you first look into the singleton types, if you have already registered a singleton type, and then if not, okay, you'll just go for the transient types and get the first value that comes through. And of course, if you don't have any implementations whatsoever, so if you don't have neither singletons nor transient, you just return null. That's why we can have a null. And yeah, let's take a quick look at the descriptor. This is like the business, how the business is organized here. So we have the type, which should be the interface. Then we have the implementation. Actually, we have two types. So we can actually provide an implementation. So when adding a new descriptor, you can actually provide the implementation yourself. So you're not constrained by the framework to use just like console writer and console writer. You can actually provide the func which gets your implementation. So you could provide it as well. They have the implementation factory. As I said, you can provide your own stuff. And then you have the lifetime, which can be either transient or singleton. So that's pretty much it. This is how you create your own dependency injection framework. You have the descriptor, lifetime, a provider, which searches for dictionaries and gets the job done. And then you have the provider, which based on the mapping you give it, it constructs the services that you want to based on the lifetime. And the collection itself, which is the container, just a basic container, like a list, an actual list of descriptors, which define how the objects should be constructed, and how we should just get them without any further calls to constructors or other properties. And we have reached the end. Okay, so what did we learn in this course? Oh my God, I can't believe it's been like 50 minutes. Time passes so fast. Okay, so why? Why do we need the dependency injection? Well, because it enables us to test our applications in the first place, and then keeps the overall architecture clean. What we did in this course, well, we talked about some of the most basic stuff, and then we went on to the advanced stuff where we built our own dependency injection framework. And the how. Now you know how to do it. Just in like these 5 classes, and voila, you can use dependency injection whenever and wherever you want. So yeah, basically in this course we looked at the principle of inversion of control and how it is achieved using the method of dependency injection. Yeah, this has been Teodor. Hope this course makes you a better developer. It's been a pleasure to present it to you. And now we can move on to questions if there are any. I want to thank Alex for the first question. He broke the ice. And yeah, just to recap, so Alex's question was that given the fact that .NET has a built-in dependency injection framework, should you use an external one? And the answer is no. You should just go with the built-in stuff, or better yet, build it yourself.
I don't think there are other questions in the chat, so if everyone wants to ask something, they can unmute. Also on YouTube, I don't think we have other questions.
Mm-hmm. So how's it YouTube streaming going?
Still live. We have, let me check. Right now we have 7 people on YouTube.
Cool.
Yeah,
that works.
Mostly going up and down. People like to also watch the recordings, so you can't take the number of attendees on Meetup for granted, you know.
Yeah. All right. So yeah, it's good that we have this nice community to build around.
Yeah, we should also go back to face-to-face.
Yeah, I prefer face-to-face. I mean, I don't know if you're the same, but I get my energy from people. Right now, I'm looking at screens. I'm seeing names. I see attendees. It's just like, if I don't see them face-to-face, I have to like create my own energy and like fool myself that I'm talking to actual people, which I'm sure you are.
Yeah, I know how it is. But yeah, I think we should do that while we still can.
Mm-hmm.
Anyway, we'll be in person in October with .NET Days. So
yeah, .NET Days, sure. We'll meet there, for sure. We'll meet there. And talking about .NET Days, yeah, since there are no other questions, I think we could approach the finish. Yeah, just a big shout out to Nick. I took inspiration from him, from his dependency injection course in .NET from Zero to Hero, and you can see Nick Chapsas in person in .NET Days. So this has been Teodor. It's been a great pleasure to talk to you. And yeah, see you soon. If not online, then maybe in Iasi to drink something and have some fun together. Thanks all.
Thank you, Teodor. It was nice having you with us today. And don't forget, for everyone, that next week we'll have another meetup with Andrei Epure. It will be about NuGet dependencies and how you can have a new type of attack. So I think that will also be an interesting presentation. Okay, so Teodor, thank you again for joining us.
Yeah, thank you, Bogdan.
Hope to see you again at .NET Days. At .NET, yes, sorry.
Sure.
Or both.
Or both. Better yet.